right, welcome back. So let's continue talking about the different types of volcanoes and eruptions. So we talked about starting from the gentlest Icelandic Hawaiian style eruptions common at fissure and shield volcanoes, and strombolian types of eruptions common for cinder cone volcanoes. Now let's start to get a little dangerous. So let's talk about stratovolcanoes, sometimes known as composite volcanoes. These are typically made and created from andesitic magma, so a little bit more viscosity, a little bit more volatile content, therefore more explosivity. They're known for creating very tall and scenic mountains. 60% of all of Earth's individual volcanoes are these stratovolcanoes. They can be extremely explosive. They're responsible for over 80% of eruptions. Most death and destruction from any type of volcano is going to be coming from some sort of stratovolcanic eruption. And these types of volcanoes are very, very common in the Ring of Fire convergent boundaries. Examples including Mount St. Helens and Mount Rainier in Washington, the San Francisco Peaks, San Francisco Mountain in Flagstaff, Mount Fuji in Japan. When these things go off, that's when large-scale death and destruction occur. Again, you can get from a volcanic eruption a moderate explosion of gas laden with volcanic ash, not a lot of lava coming out of these. Palaean explosive outbursts that generate something called a pyroclastic flow. So now we're getting into kind of really dangerous stuff. And then Plinian eruptions, intensely violent, enormous, nearly continuous jetting blasts of ash that core out the magma conduit, rip it apart. You can also get pyroclastic flows coming from these Plinian eruptions. So Volcanian eruption. So this is when you're getting this kind of more blown up explosion, ash going up into the sky. Palaean is when you get a little bit bigger explosion, but then you get something called a pyroclastic flow. More on that in a later section, rushing down the sides. And then in a Plinian, this is big time. This is big time. Mount St. Helens, this erupted with a Plinian eruption. In fact, this is an example of that, just continuous, just pumping out of ash and other volcanic material coming out of these types of eruptions. So much so, here's Mount St. Helens, what it looks like now, and you can kind of imagine what it used to look like, how much of that material has been blown away. Mount Rainier, stratovolcano. Wonderful place, wonderful national park, if you ever get to go there. I've had a chance to climb it. Guess what? I was on top of a volcano. That was in the back of my mind. Mount Fuji, gorgeous. You can see it from Tokyo. Stratovolcano. The San Francisco Peaks up in Flagstaff. There are different peaks, but it actually is just one big mountain. It used to be a very large stratovolcano, but it is erupted. You can imagine how much of it has been blown away. So, yes, we have cinder cones in Arizona. Yes, we have composite volcanoes. We also have some shield volcanoes, but not too many. But this is an interesting one. But in Flagstaff, which is located right in this area, so you have San Francisco Mountain. That's our big composite or stratovolcano here in AZ. And then all these little circles you see surrounding it, those are all cinder cone volcanoes. Over 600 of these bad boys. So Flagstaff, any hill, if you've ever been to Flagstaff, really any hill, any mountain up there, it's all a volcano. Good times. But everything up there is pretty much extinct for the most part. And then, ladies and gentlemen, that brings us to a super volcano. Now, these are rare, so they don't necessarily have their own eruption type other than really big. These are typified by a collapse of the land surface. It's associated with rhyolitic eruptions. Rhyolite, think back to that image that showed the different types of magmas, the viscosity, volatile content, explosivity. Rhyolite's up there. It has high silica content, therefore very high viscosity, meaning it's very sticky. It doesn't really want to flow. So as it's getting pushed up below ground, it kind of just gets stuck and it builds up some pressure. And you get a bunch of gas trapped in there as well because it can't get out of this sticky stuff. And then after enough pressure builds up, boom, big eruption. So you don't really see too much on the surface by way of like a mountainous volcano. It's more so a lot of this is happening underground, but when they do erupt, all that material gets blown out into the sky, leaving behind this big cavern, so the ground above just kind of falls back down into it, creating something called a caldera. But again, very violent explosions, extensive ash fall. These are the largest known eruptions. Typically, they're known to exist because of continental crusting over a hot spot. So a hot spot meant melting continental crust, giving it that rhyolitic magma consistency, very sticky, a lot of gas, very explosive. Yellowstone, Velez, calderas are some great examples of said volcanoes. So just a just a little kind of image of how it kind of works. You get a very large magma chamber. Again, oftentimes you don't see this large volcano overhead. It erupts, the magma chamber empties, the material above collapses in, creating this what's known as a caldera, this volcanic collapse crater called a caldera. Again, this is Yellowstone National Park. This is the Yellowstone caldera. So this is all that material that kind of fell down. The thing with the Yellowstone eruptions and the volcanoes, Yellowstone supervolcano, excuse me. So looking at one of the last eruptions, 640,000 years ago, from the Yellowstone supervolcano, you can see the extent of ash fall. Again, when you're looking at some of these more explosive volcanoes, it's not a lot of lava that comes out of there, but more pyroclastic material, rock material, ash. And if you look at the ash cloud that was erupted and settled from the last Yellowstone eruption, it's massive. It's half the country. Compare that to what some of us know and have seen in the past, the Mount St. Helens eruption. Look at its ash fall. That was a huge eruption. Look how little ash there is compared to, for instance, the Yellowstone supervolcanic eruption. Oh my, oh my, oh my. Another great example is the Velez caldera, right in New Mexico, just north of Albuquerque, kind of Albuquerque, Santa Fe, kind of in between. So this is a satellite image of the area. Can you see the caldera? Right in there. Can you kind of see it? It might be hard to see. You have to train your eyes. But this kind of flat depression in the surrounding area. You can see how everything kind of radiates away from that central kind of area here. Another kind of image taken from like a plane of that dropped caldera. You can see it's 20 kilometers in width. So that's 12, 13 miles or so. That whole area just exploded. My goodness. Absolutely enormous. So again, you get some large magma chamber underneath. It erupts. It creates a caldera. And then in some cases, you can get a resurgence if magma comes back, starts to push it back up. That's exactly what's happening in Yellowstone. Using different satellite imagery, we can see that the Yellowstone area, even though it erupted, it's actually erupted a few times in the past, it seems to be primed to erupt again because we're seeing a resurgence of that caldera. That means the magma chamber below is filling back up, pushing that drop down portion, pushing it back up, and we can see that in satellite images. So watch out for Yellowstone National Park. Super volcano. Let's go ahead and pause there. When we come back, we'll talk about some of the hazards associated with volcanoes. Lava really isn't too much one of them. You know, when we think volcanoes, we think lava. It's not really a hazard we should be most concerned about. Concerned, but maybe not most concerned about. In any case, I'll see y'all back here in just a second.